welcome to the Ricci Flow Nutrition Podcast. My name is Cameron Borg, and today I had the pleasure of speaking with Pran Yoganathan. Pran graduated from medicine from Otago University in New Zealand and completed his advanced training in gastroenterology here in Sydney. He is a fellow of the Royal Australian College of Physicians and a member of the Gastroenterology Society of Australia. Pran's approach to gastroenterology is considered and broad. His attitude towards the human gut is informed by evolutionary principles and the vast and important contexts that surround the function of the gut. He is not steeped in dogmatism and continually seeks to expand his understanding regarding the role of the human gastrointestinal tract in health and disease. I had a wonderful conversation with Pran. He's so clearly aware of the unknown unknowns in medicine and speculates only where there is an evolutionary basis for his ideas. He is very forward-thinking in a field that can be so far behind the research. While we both agreed that the field is very much in its infancy, we discussed the evolutionary basis for the development of our unique gut. While this episode is a shorter one, I hope you can enjoy it and get a lot from it. Pran and I hope to be able to do a part 2 sometime soon, where we can go into even more depth. With all that being said, I hope you enjoy the episode. Hey Pran, thanks so much for coming on today. I'd love to know a little bit about how you got into all of this, because when you would have started researching, all the literature regarding the gut and the microbiome would have still been very much in its infancy. So what got you interested in all of this?
Thanks, Cameron. I've always taken a basic, sort of a fundamental approach to healthcare. I think I've always been fascinated with the role of the gut microbiome in modulating health and disease, for that matter. It's a topic that's relatively in its infancy. One would have to say that it's an emerging science. So I don't profess to be an expert on it. It's something that we're trying to understand and fathom. It is a colossal mystery as it stands at the moment. With regards to how I practice and how I sort of fell into it, I think it's a bit of frustration with the current allopathic model of medicine, which is really a disease care system rather than a health creation system. We term it healthcare, but it's very much focused on disease and patching up disease. So I think being a gastroenterologist, I saw the role that food or nutrition played in the etiology or the contribution to disease. So I think a few years ago, this is how we started going down the pathway of could nutrition help modulate disease. And I think we, through experience, we understand that very well. And that's a very well understood facet within the medical system. However, it's poorly implemented and very rarely given as advice. And of course, because of that, it's poorly adhered to by the patients.
That's I think there's a common thread with a lot of doctors who are feeling the same way as you. I'd love to jump straight into it and ask you about something that's quite popular at the moment, this idea of a leaky gut with this gut permeability. I'd love to get your take on what is leaky gut and what's causing it and what can we do about it?
Yeah. Cameron, again, this stuff is very much in its infancy, but the way I understand it as a gastroenterologist is we've got this system called the small intestine, which is essentially a 4-meter length segment within our gastrointestinal tract, a very important segment that looks to maximize absorption capacity. It's lined, and you can see this when you're doing endoscopies and colonoscopies and so forth. You can see the presence of villi, which are these finger-like projections as you insert the camera into the small intestine. Now, the function of the small intestine is to basically, one of the major functions is to absorb, right? And so the villi increase the surface area. And if you were to spread the villi up and measure the entire surface area of the small intestine, it would cover a championship tennis court. That resides within our gut. So we're really built to maximize nutrient absorption. Now, as you may know, the gut is a barrier to the external world or to the environment. So we ingest a whole heap of nutrients with what we take in, but we also ingest toxins, we ingest bacterial components, we ingest toxic chemicals and anti-nutrients within food, as you will know. And part of the function of the small bowel is to keep that out, yet filter in and absorb the nutrients. So the small bowel in itself should be an impermeable barrier to these external environmental aspects of what may be some of the negatives in our food. Now, with leaky gut, as it's colloquially known, in the internet space, it's fundamentally a impermeability of that barrier. This one cell barrier that's held together very tightly by the small intestinal cells via something called tight junctions, fundamentally opens up. What triggers that, we don't know. There is some speculation. Pesticides such as glyphosate could be involved, but there's a whole heap of pesticides that are used in modern agriculture. But we also think excessive fructose might be problematic to the human gut. Alcohol, food colorants, additives in food, even excessive consumption of refined fats might be a problem. Excessive bile acids might be an issue. There are many factors that modulate it. Some of the other triggers that are commonly thought to do it are also lectins like gluten, and this might sort of explain why we might have a bit of an epidemic of non-gluten sensitivity in those that are non-celiacs. It potentially could be modulated at a small intestinal level with impermeability, or as I said, colloquially known as leaky gut.
Yeah, is there anything that can modulate it in a positive way for health? Help to selectively bring those tight junctions back together where they need to be.
Yeah, I don't think the research exists, Cameron. I don't think the research exists, so I'm always hesitant to state things that are not backed up by research. However, to me, if we feel that potentially gluten might be a trigger, alcohol might be a trigger, refined fat might be a trigger, and potentially excessive consumption of fructose might be a trigger, well, let's start at a very simple level and look to eliminate those things, or at least minimize them. Colorants in food, and these are things that are very, very rich in processed foods that come out of packets. Additionally, I think it's worthwhile knowing where your food comes from. I think it's all very well to eat fruit and vegetable, but how have they been treated? How have they been processed? I think it's really important to know that. So I think these are some of the ways in which we can look to improve our gut health, so to speak, or the permeability that results from living in the modern world. But there's no hard and fast rules to it. There's no established science as yet. It's very much an emerging field.
Yeah, absolutely. I feel entirely the same way. The human gastrointestinal tract is an absolutely amazing feat of engineering. It's really incredible when you have a look at it. And something that fascinates me the most is how can the stomach withstand such amazing acidity? You've spoken a little bit about PPIs and their role in chronic disease. I'd love to hear a little bit more about the role of proper acidity in the stomach for not only for gastrointestinal health, but for metabolic health as well.
Yeah, I mean, I think you describe it in a very good way when you call it an amazing feat of engineering. And one of the things that I've done as a gastroenterologist is try to reverse engineer the human gut as to figure out its function. What are we best suited to eat? Now, the stomach being acidic it's an unusual feature amongst primates, and we are a primate, a species of ape. We are probably one of the only primates that has an acidity at that sort of level. I mean, we can, in young, healthy people, the pH can be low, very low. I mean, the pHs of 1 and some people under 1. This tells us that we are built to eat high-risk foods that should be decontaminated first. And one of the biggest high-risk foods we can consume is fundamentally meat. And we spend a lot of our time through our evolutionary past evolving in the savannas of Africa, eating a lot of rotting meat. I mean, we were fundamentally scavengers. And we've got to remember refrigeration was only about 100 years old. Prior to refrigeration, a lot of these foods would have been excessively or would have been contaminated. This is what our ancestors ate. So to have stomach acidity in those sort of areas would have been extremely effective for decontamination. Now, the second aspect of acidity is it helps expose protein binding sites. So it's fundamentally the acid is most effective to break down protein. Okay, so that's where the protein breakdown in the stomach occurs, whether that's plant or animal protein. Now, in terms of the modern world, however, we're on these very high carbohydrate, high refined fat, low protein based diets. So I just wonder whether there's an evolutionary mismatch there where there is too much acidity too much acidity that fundamentally isn't required for the modern way of eating. And potentially this is why people are suffering issues related to, in inverted commas, acidity. And this might potentially explain the widespread use of proton pump inhibition and so forth. There is even some school of thought that the bacteria known as Helicobacter pylori might have been a symbiotic relationship which looked to make the stomach even more hostile and more effective at decontamination. So there's a lot of aspects to that we need to understand and we need to clarify further with emerging science. But to me, there is no doubt that we are a primate that is built very much on that carnivorous spectrum to decontaminate these high-risk foods. There can't be any other reason, a plausible reason for why our stomach would be that acidic, especially when you look at animals with 99.8% similarity in their DNA, such as the chimps and gorillas and stuff. They just simply lack that level of acidity. It serves a function. It's not there as a freak event. Everything in nature, as you know, must serve a function.
That's I like your view on that, because it's quite a marked difference between us and our closest ancestors. Another thing connecting us is the role of fiber. What do you think the role of fiber is fundamentally in the human diet?
Yeah, fiber is beneficial. I think we've existed at most of our evolutionary history. We've existed in a very low calorie, low nutrient environment. Food was scarce, and agriculture changed that with increased food security, so to speak. But the quality of the food produced through the agricultural revolution potentially diminished as we went from being hunter-gatherers to farmers. So what I'm trying to say, Cameron, is we as human beings, we are built to maximize our energy production and consumption at every single level. So the role of fiber, it really serves no role within our small gut. Our small gut can't break it down. We lack the cellulases required to break it down. But where fiber is interesting, and you've got to divide it up into insoluble and soluble fiber. I think soluble fiber is far better. Insoluble fiber can trigger a lot more gut symptoms in people, but soluble fiber and non-absorbed carbohydrates both trigger the same way by the large bowel, where it's taken into the colon, which is the right side of our large bowel. And the microbiome, which is the richest point for the microbiome to exist, is in our colon, especially in our right colon. They start fermenting these fibers, okay? And they utilize that as a food. They have the ability to break it down. So because we've got this symbiotic relationship with our microbiome, they give us 10% of what they generate. And what they generate is fundamentally short-chain fatty acids, which is the ketone. short chain ketone, which is beneficial. It can be used up by the colonocytes, which are the cells lining the colon. It can be taken up into your portal circulation and disseminated to the brain. It's a great fuel for the brain. So we can use fiber to create a ketone, which is fundamentally fat, which is what the mitochondria, the energy cells, or the energy production sites in our cells use to create energy, which is ATP. Energy is ATP. So what we're doing with fiber is we're using an ingenious relationship with the microbiome to help generate 10% of what they make, but 90% of what they make they keep for themselves, and that makes sense, right? Like that they're generating it for themselves, and we're sort of taking a little bit for hosting them. But the other byproduct of that fermentation, methane, hydrogen, nitrogen, these gases that are released, and this is why sometimes excessive fiber consumption can lead to gut distress. We as humans, our hind gut had to shrink, right, compared to our primate cousins. So compared to the gorillas and the chimps and the orangutans and so forth, our colon is extremely thin compared to them. And it shows that we moved away from utilizing fiber as a fuel to utilizing more nutrient density as a food. And therein lies the difference. We still retain some of that ability to ferment the fiber, but it's different. It's changed. Whereas for creatures such as the chimps, they are more reliant on short-chain fatty acids. And when you look at creatures like the horses, 50% of their energy production comes from fermentation of short-chain fatty acids. Whereas for humans, the estimate is less than 2 to 3%. For pigs, it's about 5%. For chimps and gorillas, it might be higher at 10 to 15%. So it shows that we relied on it very little over the evolutionary history, but it does serve a role. I think as human beings, it's important to be metabolically flexible, to utilize the body the way it was built or evolved to function. So I don't see an issue with fiber. It can be satiating. High fiber foods are satiating, but I think one of the key mistakes that's made in nutrition, in your field and mine, which is medicine, is fiber is referred to as a nutrient. It's not a nutrient. It is basically a framework which nutrients can come into, but our body can't utilize it, okay? And I think we push high fiber diets onto people that are sarcopenic, elderly people that are lacking muscle mass, and therein lies the issue that we are basically there's a lack of education about how it actually works. Does that make sense? So sorry, it's a long.
No, definitely. I think some people throw the baby out with the bathwater with fiber. I'm a fan of fiber as well, but I think we need to understand what its role is, and we're probably still figuring that out. But I thought your answer was very considered. I'd love to know your perspective on SIBO. I've been very skeptical of this whole idea that there's a growing faction of people that are struggling with this small bowel intestinal overgrowth, and they're going on low FODMAP diets, and I'm not sure about the testing mechanisms, and I'd just like to get your opinion on it as a gastroenterologist.
Yeah, it's interesting. I mean, it's referred to as small intestinal bacterial overgrowth, but the reality of the situation is the action's probably occurring in the large colon. I think, as I've said to you, I think if 90% of our food is grain, processed grain, which is the reality of the modern living, where 15,000 years ago that made up 0% of our diet. Grain was not a part of our diet, in particular processed grain. We're probably tending to malabsorb a lot of these components, and it ends up in the large bowel being fermented away. And I think over time you just start selecting for bacterial species that are problematic. Now, very rarely is it an issue if your food is non-processed, but I'd say probably 80% of our food is now in the modern world processed, heavily processed. So I think over time your microbiome just shifts, and I think a lot of the issues is happening downstream in the large bowel. But people like to isolate things and categorize things. But really, if your large intestine and your microbiome there is not working well, you'll start seeing alterations even in your oral microbiome. So, people tend to think bad breath and halitosis and is related to oral hygiene. No, a lot of it is related to your microbiome. So an alteration in your colonic microbiome will alter your small intestinal microbiome, which in turn will alter your esophageal microbiome and also your oral microbiome. Very little exists in the stomach, of course. There's only a few bacterial species that can exist there, such as Helicobacter pylori. So the stomach doesn't carry a microbiome, so to speak, because of the acidic environment, but then we're using proton pump inhibitors. So perhaps there's overgrowth within the stomach. It's just a mess, really, Cameron. I think we are a primate that thrived on nutrient density. We were hunter-gatherers. Where animal protein in particular, was prioritised. Yet we live in this modern era where we're sedentary with nutrient-dense foods that are vilified. Red meat's vilified. It's a source of cancer and heart disease if you talk to 90% of my colleagues. So how can we have a chance to have good gut health if this is what's going on? So I don't buy into this whole concept of small intestinal bacterial overgrowth or SIBO. I think there's a lot of expensive tests out there for it. If someone's struggling with abdominal bloating, gas, erratic stooling, pounds to peanuts, that small intestinal bacterial overgrowth test is going to come back positive. It's often a breath test. I think you just listen to the patient and ask them, are you suffering flatulence? Do you have bloating? Do you belch a lot? Most people tell you that they do. So eliminating some of these foods that tend to ferment a lot might be a start. That's stop fire. That's not what I'm saying. But eliminating some of these FODMAP type carbohydrates would be a start. The problem with the low FODMAP diet, the way I see it, is they ask you to eliminate a lot of things, but they don't allow you to add in things. So people can't adhere to it for very long because they're hungry. Like, well, if you don't want me to eat bread and pasta and grains and cereals, what can I eat? Well, we should be telling them to emphasize protein, quality animal-based proteins that are low in FODMAPs, but we don't do that because we've linked it with disease. We've said this stuff causes disease. So it's a catch-22 situation, a vicious cycle from which patients cannot leave. Hence, adherence is low. So they just go back to eating the way they do, and the cycle of disease continues. And patients often just learn to live with it and just label their bowels as being irritable, which is the concept of irritable bowel syndrome, which I think 99.5% of it is probably caused by diet. It's modern living.
I couldn't agree more with what you've talked about just there. Moving in a bit of a different direction, I'd love to talk about the role of hydration in gut health, something that I think is often overlooked. Do you find that a lot of people that you're seeing that are struggling are just simply not drinking enough water and that's contributing to their problems?
Listen, Cameron, that's an interesting one. I'm not sure about that. I think water is important, but my philosophy has always been drink when you're thirsty, right? Like your body tells you. When it's thirsty, just drink when it's thirsty. I think people overdo water sometimes. I think people have got these goals to drink 4 liters of water over the course of the day. I don't quite understand that. I think they're probably flushing out electrolytes with it as well. That's a problem because you're ending up with electrolyte depletion. I mean, when you consider we evolved endurance hunting on the savannah in 40-degree heat with no ability to carry water, and again we're a primate that's built to be resilient, to be sturdy. We don't need to nourish our body with water every 5 minutes, and you see people walking around carrying these big drink bottles. I think again it speaks to the modern day diet. I mean, if your diet is 90% carbohydrates, there's a lot of glycogen being generated in your liver that has to be stored somewhere. It's stored in muscle. Glycogen can't move in without water. So a lot of times people on these high carbohydrate diets, they're waterlogged probably because glycogen needs to move in. But I tend to find that on a really nutrient dense diet where you're perhaps not overdoing your carbohydrate intake or matching it with your levels of exertion, earning what you're eating basically, the requirement for water is probably not all that high. You just drink when you're thirsty, really. Basically, I think it's pretty simple. We're the only species of animal that needs to be told how to eat and how to drink. We've lost our way, Cameron. What used to be inherently instinctive is fundamentally confusing to 99.9% of the world now. So this is the paradox of life.
Yeah, definitely. There is an emerging link between gut dysbiosis and metabolic disorders, whether it's type 2 diabetes or even cardiovascular disease. How do you see those how is the gut microbiome playing a role in these metabolic diseases? It seems something that shouldn't be connected, but they clearly are.
Yeah, I mean, that's an interesting one, Cameron. I'm not sure that it's it's the cause per se. I think it's correlation versus causation. I think a really poor diet will fundamentally lead to metabolic dysfunction through mitochondrial dysfunction, largely speaking, which is pouring in fuels, pouring in refined fat and refined carbohydrate into these mitochondria that are basically hammered. These are the energy production centers of our cell. As you know, we start storing these energy intake as fat deposits within our system. So you get mitochondrial dysfunction. But the same food ends up in our gut. So in essence, someone who's metabolically disordered is also likely to have dysbiosis because the gut microbiome has to deal with that stuff going in. So it's the concept of correlation versus causation, right? Like, I don't think dysbiosis in itself is the cause of obesity. I think dysbiosis will correlate very, very strongly with obesity and metabolic disease because things are fundamentally driving it, which is modern day diets and of course, sedentary behaviors. We know that even exercise can change your microbiome. It can influence it. So I think those two things are key: nutrition and movement, and those things are definitely disordered in modern living.
Yeah, definitely. What's your view on probiotics then? There's an awful lot of maybe false advertising out there about what they can do. I'd love to get your perspective on the role of probiotics, if there is one.
Yeah, sure. I mean, the latest reviews that I've seen on it from the American Journal of Gastroenterology suggested it has got very limited use. It's got no use in the setting of inflammatory bowel disease, irritable bowel syndrome, reflux, obesity. It's got no role. There's no convincing evidence. However, it's a multi-billion-dollar industry, and corporate forces that dictate these sort of things will basically try and maximize that. And then I think that they're being advertised and sold and people buy them, but I'm not sure that they've got a role. It's, to me, getting good gut health is not about what you add in, it's really about what you take out, and eliminating aspects of our diet that might be triggering dysbiosis rather than adding something in to try and fix something that you're destroying through everyday eating. Does that make sense? I mean, to me, expecting probiotics to change our gut microbiome, it's like walking up to the ocean with a cup of red ink and saying, look, I'm going to stain this ocean red. It's a colossal trillion number. Our microbiome numbers in the trillions, 40 to 80 trillion. There's more microbiome based bacteria than there is human cells. So I don't think we can hope to change it with a billion, capsule containing a few billion probiotic bacteria. I think it's really about what you eliminate slowly in your diet that is more likely to be beneficial. Certainly if you look at the hunter-gatherers or early humans, they didn't have probiotics. And they would have had great gut health. The hunter-gatherers do. They've been studied and they've got amazing diversity in there, but we lack diversity and we tend to carry a lot more of a pathogenic signature when it comes to the microbiome. I think it's what we're eating. It's not that we've got a probiotic deficiency. It's what we're putting into our gut.
Yeah, I couldn't agree more. You mentioned movement before, like exercise, being able to change the microbiome. We know that things like exercise, even sunlight, have quite a marked effect on the diversity and the makeup of the gut. Is this something that you are probably more interested in at the moment?
Yeah. Listen, I didn't realise the sunlight did, but I'm not surprised about that. That doesn't surprise me at all. It's something that I'll do a bit of reading on. So thank you for introducing me to the concept. But yeah, absolutely, right. Like if you're engaged in the extremes of exercise, you're burning fat as a fuel. You're liberating something called beta-hydroxybutyrate. Beta-hydroxybutyrate from your fat stores, which is a ketone. Ketones can peripherally nourish the colon. So I think the colon in the modern world suffers this horrible energy starvation because we are not able to ferment as efficiently because of the dysbiosis. Plus, a lot of people are on really low fiber diets anyway. But I think if you're burning fat for energy, you're liberating the ketone in your circulation, in your bloodstream, which will then nourish your colon. So I think exercise is great for the colon. And like you talk to people anecdotally, they'll tell you their bowels work better when they're exercising. And there's a reason for that. There's always a scientific reason for everything. And the reason for it is they're nourishing their colon fundamentally through breakdown of their fat stores. Fat is an important fuel to burn. In the modern world, we've forgotten how to burn fat. We are obsessed with the concept of burning sugar. We've been indoctrinated by the dietary guidelines, which have suggested that, you have to be eating sugar 5 times a day to be able to keep your blood sugars up. We've forgotten that we have this wonderful ability to burn this fuel called fat. We're basically a hybrid vehicle capable of burning 2 types of fuels, and we very rarely burn as a fuel. And this is why we've got excessive fat storage, we've got obesity, we've got metabolic dysfunction. Really, it's not all that hard to see where things are going wrong.
Yeah, awesome. Before I let you go, because I know you're busy, you mentioned before that about 90% of your colleagues in gastroenterology would probably be on the end of demonizing red meat. I was wondering why is your perspective different in your eyes? Why is red meat so important?
Well, red meat's an extremely nutrient-dense source of extremely nutrient-dense. It's been eaten for 4 million years. The studies linking it to colorectal cancer are extremely weak, usually not able to be replicated. There's multiple systematic reviews that have been conducted, even by the father of evidence-based medicine, who's Gordon Guyatt, who questioned all of this. The evidence is really weak, yet we've been very quick to label a whole food, a non-processed whole food, as a source of cancer. That to me begs that I'm blown away by that. I think processed meats are a different story. Of course, the processed meats come with a package that's pizzas and burgers and fries and refined fats and ketchup and drinks and so forth. So to me, that makes sense as to why processed meats might be problematic. But again, it reflects to the package that it's delivered in. And so when you talk to people about could you look to increase your protein intake, they're very reluctant to do so because they're reading newspaper articles every day linking it to disease. So I just don't see good evidence for that, and I think we have to be very wary of labeling animal-sourced foods as a cause of cancer when they're unprocessed, especially when we're suffering an epidemic of under-muscled people with really poor metabolic rates, which leads to metabolic dysfunction. We've got osteoporosis. We forget that 50 to 60% of our bone matrix is made up of protein. We're on extremely low protein diets because protein is apparently killing us. Animal-sourced protein is killing us, according to popular research. And I don't think many people in my industry are questioning that enough. They are basically following the guidelines. I mean, you look at Bowel Cancer Australia's rhetoric, meat-free weeks, and Cancer Council Australia, which again demonises red meat. I think this is all being done very unfairly based on questionable evidence. And me as a scientist, I just want to see better quality evidence before we label red meat a carcinogen. I think it is an extremely nutrient-dense source of food for iron, choline, just a whole heap of factors, B12. There's just a lot in there that people could use. And we've got malnutrition at a very heavy level in Australia. We think that obesity doesn't correlate with malnutrition. We think obesity is excess of nutrients, but it's not the case. Obesity at its core is malnutrition. It's just an excess of energy leading to fat storage. So I think we should be nourishing our population, and I think red meat is a great way to do so. But sadly, I think there are a lot of barriers against that.
Yeah, I couldn't agree more, and hopefully we can get together and continue talking about this, and then maybe we can delve into the difference between grain-fed and grass-fed at a different time. But I know you've got places to be, so I'll thank you so much for coming on and speaking with me, and hopefully we can do this again sometime soon.
Definitely, I promise to do it again, Cameron. You've asked some really good questions, and I appreciate the discussion.
Awesome. Thanks so much, Pran.
Thanks, mate.
Thanks so much for listening. I hope you found this episode insightful. I've been busy organising so many new podcast guests for the coming months, so please make sure you keep up to date with what I'm doing. To keep up with my work or to seek a consultation, you can find me on social media using @Ricci Flow Nutrition. So thanks for listening, everyone. Take care.